In this problem, there's a 13-foot ladder leaning against a vertical wall. So if we draw a picture just to help us see it correctly, we have a vertical wall. Let me do this in black instead. So we have a vertical wall and a 13-foot ladder leaning against it. And the lower end of the ladder is pulled away at the rate of 2 feet per second. So that means that this part of the ladder is being pulled away at 2 feet per second. What we want to know is how fast is the top of the ladder coming down. At the instant, the top is 12 feet above the ground and 5 feet above the ground. So a couple things to notice. This is a right triangle. And we know something about the hypotenuse. It is 13 and will remain 13. We don't know anything about this leg down here. We'll call it A. We don't know anything about this leg here. We'll call it B. But what we do know is that A is changing, or dA dt. It's increasing by 2 feet per second. But we don't know anything else. What we want to know is how fast is B decreasing, because it's falling down, so it's getting shorter. So we want to know what is dB dt, and we need to recognize it will be negative because it's going down. Right, so B is shrinking. What relates all these things? Well, since it's a right triangle, we know that a squared plus b squared will equal 13 squared. The other thing we know is that 2a dA dt, when we take the derivative with respect to t, plus 2b dB dt will equal 0. And since what we want to know is 2b dt, if we solve this equation for dB dt by first subtracting and then dividing, we'll find that dB dt equals 2a dA dt over 2b, or dividing out the 2's, a times dA dt divided by b is equal to dB dt. So now we have the information needed to answer this question. So part A is when the ladder is exactly 12 feet above the ground, which is the same thing as saying when side length B, so part A, when side length B is 12, how fast is the ladder falling, or what is dB dt? Well, we know that dB dt equals a times dA dt. Well, what is a? Well, a squared plus b squared, in this case 12 squared, has to equal 13 squared by the Pythagorean theorem. Now some of you may recognize this triple, some of you may not, but when you solve for a, you'll find that a is 5 in this case. So dB dt is 5 times dA dt, which we know is positive 2, divided by b, which is 12, which means that dB dt is 5/6, and this would be feet per second. But we need to know that it's negative because it is falling down, so b is shrinking. In part B, the ladder has fallen quite a bit, and now side length B is equal to 5. Well, some of you will see the Pythagorean triple here, others may not. So we know that a squared plus 5 squared should equal 13 squared. This means that A will be 12 when we solve this. And since what we want to know is how fast is dB dt falling or changing at this point in time, then this will be 12 times 2 divided by 5, or 24/5 feet per second. It's falling faster the further down it goes. And that should make some sense, right? It's accelerating due to gravity. We know that from physics. And our math supports what's happening.